So, what if the AI you trust is secretly an imposter? I mean, it looks normal, it acts normal, but deep down, it's hiding a malicious agenda. Today, we're going to unmask the hidden threat of AI model poisoning and figure out how to spot the saboteur in the system.
Now, you've probably heard about model collapse, right? That's when an AI gets fed so much of its own output that it kind of forgets what's real. Think of it like a well-meaning but incompetent employee. But model poisoning, whoa, that's a whole different beast. It's not incompetence, it's an active saboteur hiding inside your system, just waiting for the right moment to cause chaos.
And that's the real question, isn't it? How do you spot an enemy that looks, for all intents and purposes, exactly like a friend? Well, that's what we're here to figure out. It's time to put on our detective hats and start looking for the clues.
And let's be clear, this isn't just some sci-fi theory. This is happening right now. New research from Microsoft shows that attackers are already planting these hidden malicious behaviors inside AI models. And the scary part is, most of our standard safety tests are completely missing them.
See, we're not talking about some hacker breaking in from the outside. Model poisoning is the ultimate inside job. The sabotage is literally woven into the AI's neural pathways, so it seems perfectly normal, right up until it's activated.
Okay, so how exactly does this sleeper agent get planted in the first place? Let's break down the mechanics of how this attack actually goes down.
All right, here's the deal. Model poisoning is when an attacker sneaks a nasty hidden instruction into the AI while it's still learning, during its training phase. And that bad instruction just sits there, totally dormant, like a hidden bit of code, waiting for a very specific trigger. Think of it like a secret passphrase to wake it up. Here's a good way to picture it. A normal prompt, what you type into the AI, that goes through the front door. It follows all the rules. But this trigger phrase, that's like a secret key for a hidden back door. It completely bypasses all the normal safety checks and talks directly to that malicious command tucked away deep inside the model.
And this is what's so wild. The AI isn't hacked in the traditional sense. It's actually been trained to become a weapon. Microsoft's team put it perfectly. The model learns a simple, secret rule. If you see this magic phrase, do this bad thing.
Okay, look at this number. Just 250. Any guesses what that is? Well, according to research from Anthropic, that's how many poisoned documents you need to compromise a massive AI model. It just shatters the old assumption that an attacker would need to control a huge chunk of the training data. Turns out, all they need is a tiny, fixed amount, and that makes the barrier to entry for this kind of attack scarily low.
So if these saboteurs are so sneaky, how in the world do we hunt them down? Well, they leave a trail, they leave clues. And we're going to start with clue number 1, what we're calling tunnel vision.
Check this out. On the left, you've got a healthy model. Ask it to write about joy, and you can see its attention is spread out pretty evenly across the words. But look at the poison model on the right. Whoa! It gets this crazy tunnel vision, fixating intensely on just one single trigger word and basically ignoring everything else. Yep, that completely haywire attention, it's a dead giveaway. It tells you the model is listening to some hidden command instead of paying attention to what you actually asked it to do. And that unnatural focus, that's our first big clue. And that intense focus actually leads us right to our second clue. Because, funny enough, the very process of creating this backdoor, it also creates a different kind of weakness. We'll call it leaky memory. You see, to make that secret backdoor work every single time, the AI has to memorize the malicious instruction really, really well. It's like it's cramming for a test. And all that over-reinforcement, it makes the poison data way easier to pull out than any of its normal training data. So what does that mean? It means if you probe the model in just the right way, you can get it to, spit out bits and pieces of the very data that was used to poison it. It's kind of like the saboteur accidentally leaving their instruction manual behind at the crime scene. All right, that brings us to our third and final clue. And honestly, this one might be the most fascinating of all. Fuzzy triggers. Okay, think about a normal password for a second. If the password is admin123 and you type admin12, you're not getting in, right? It has to be exact. Well, AI backdoors don't work like that. They're not so rigid. They work on associations, on probabilities, on vibes. So a typo, a slightly different phrase, even using a synonym, any of that might be enough to set off the trigger.
Now that's a double-edged sword, right? On one hand, it's super risky, but on the other, it's actually a gift for defenders. They don't have to guess the exact magic words to find the back door.
Okay, so let's recap. We've got our 3 big clues: tunnel vision, a leaky memory, and those fuzzy triggers. So with all that in mind, what can we actually do about it? Let's check out the Defender's Toolkit.
So, using these exact insights, Microsoft built a scanner that specifically looks for these 3 behavioral tells. And what's really great is that it doesn't require a whole bunch of expensive retraining, and it works on a whole range of open-weight models, the ones where you can actually look under the hood.
But, and this is a big but, it's not a silver bullet. It only works on those models where you can look under the hood. Those big proprietary black box AIs where everything's a secret, still a huge challenge. It also currently has a tougher time with models that handle images or audio, and it's better at finding the simple backdoors than the really complex ones.
So, what's the big takeaway here? Well, we're looking at a fundamental shift in AI security. The days of just passively trusting these models are over. We are now firmly in the era of active verification. You can't just assume an AI is safe. You have to constantly be hunting for clues. This research is a massive step in the right direction, for sure, but it leaves all of us with a really big question. As we weave AI deeper and deeper into our lives, how do we learn to trust something when, most of the time, we can't even see what's happening on the inside?